Hello, Algebra 2. This is Mrs. Avila, and I'm here to continue graphing logs. I know we got cut off a little bit at the end of class, only getting to do one example, so I wanted to show you one or two more just to hopefully help ease your mind and show you how easy we can make them as long as we understand the inverse relationship. So I'm going to start off with just a quick reminder. Remember that f of x really is the same thing as y, so I can actually rewrite this function as y equals log base 2 of x. Now, as Mr. Han mentioned in the preparation video, what we want to do is we want to recognize that I don't actually have a log base 2 button on my calculator. In fact, I haven't worked much with logs at all at this point. And so to graph this, it might actually be easier to graph it if it were in exponential form. Well, good news is we have talked about how to switch between log and exponential form. And so if we do so, it might be easier to plug in values to graph. Now, Mr. Han showed that if you simply go from the log form, you can actually just very quickly rewrite that as 2 to the y equals x. But if you have me, I actually showed you another trick as well. I call it g-force. And g-force is a little pattern that I 100% just made up. There's no real mathematical seriousness, I guess, to it. But what it does is it allows me that if I would like, I can rewrite my log equation, putting the log on the left-hand side. And if I start with my base of my log and I do this little funny swoop around, hence why it's called g-force, it looks kind of like a funny looking sideways G, that'll actually tell me the exact order to write it in exponential form. So 2 to the y equals x. I think of this green line as like my little roadmap, the order of the parts that I pass. Okay, so regardless, if you follow Mr. Han or if you use my little strategy g-force, either one, you get the same equation. So here's the thing. If we can graph this right here, we will ultimately be able to get the original graph in turn. Okay, so here we go. I'm going to make an XY table, very similarly to how you've done for years now, right? But when I look at this equation, I notice that I have 2 to the y equals x. Normally, I would see an equation in terms of x solving for y. So all this tells me is instead of plugging in x values, let me plug in y values and get my x in return. So I'm going to pick some y values instead to plug in. And when I plug in those various y values, I'm going to get x back, okay? So if I do 2 to the negative 3, well, 2 cubed is 8, and the negative is what's going to flip it, so that's 1/8. 2 to the negative 2, that's like 2 squared, which is 4, but it's going to be flipped. And then I'm going to have 1/2, 2 to the 0, anything to the 0 is just 1. 2 to the 1 is 2, 2 squared is 4, 2 to the third is 8. So now, the fact that I plugged in y values and got my x's in return, I've actually solved for my points of my original equation, log base 2 of x. Now I can just plot them like normal. So I'm going to pick a color here that'll stand out a little bit more. I'm going to zoom in a little bit because my graph, some of my values are quite small. For my x, I'm going to go over 1/8, and I'm going to go down through negative 3s. There we go. I'm going to go over 1/4, down negative 2. Quite a few of these are going to feel kind of crumped together. There we go. 1, I'm at 0. 2, I'm at 1. When I go over 3, 4, I'm at 2. And then I go over 5, 6, 7, 8, I'm at 3. Okay. So you'll see that your log function, it's kind of writing right along that y-axis. In fact, that y-axis right here is actually very special. We call a line of which the graph starts to approach, gets very, very close, and kind of just rides along it. We call that an asymptote. Okay, and so I'll just shorthand it, asymptote. The asymptote is that vertical line that the graph gets very close to, and in this case, I would say x equals 0. My domain is, remember, all my x values, and in this case, since I have that asymptote cutting off my x values, I'm going to say my domain is all x's just on the positive side, greater than 0. And my range, remember, that's my y values. There's no asymptote, there's no horizontal line cutting off the graph going up and down, so my range would just be all reals. All right, let's look at one more. I'm going to zoom back out so we can see everything. So this case we have graph f of x equals log base 1/2 of x. All right, so in this case, I'm going to do a similar thing. I want to rewrite it as y equals, just so it's a little bit more comfortable of a form. And then I'm going to write that in my other form, which is 1/2 to the y equals x. Remember, if you like my g-force strategy, you could go over here and you could have just written it as log base 1/2 of x equals y. And if you do my little g-force pattern, you get 1/2 to the y equals x. Notice it's the same thing. All right, so this is what I'm going to graph. Since I'm going to graph it by plugging in y values instead, I'm going to pick some y values, -3, -2, -1. Just going to pick a variety, and I'm going to plug those in for y. So 1/2 to the -3 is 8. 1/2 to the -2 is 4. 1/2 to the -1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4, and 1/2 cubed is 1/8. So I'm going to graph that, and that will give me my original function that I was trying to graph from the beginning. I'm going to go over 8 down 3, so 1, 2, 3, 4, 5, 6, 7, 8. All right, so I got my point right there. Then I'm going to go over 4, 1, 2, 3, 4, down 2. I'm going to go over 2 down 1, 1 at 0, 1/2 at 1. I'm going to go over a quarter up 2, and up an 8, or over an 1/8 up 3. So you'll notice this one also has a very similar kind of curve to it. It also, sure enough, looks like it's gliding along that x equals 0 line. So again, I'm going to say my asymptote in this case happens to be x equals 0. I'm going to do my domain, and I'm going to do my range. Remember, my domain are the x values, my range are the y values. My domain is all x's on the positive side, and my range is all real numbers. All right, hope those couple examples help. Please let me know if you have any questions. Otherwise, have a great day.